Hi guys, Dave with AirSpool here, and I have to admit that in the past I haven't spent a lot of time worrying about or researching global warming or climate change or what may be causing these things, but I have now, and I'd like to share my findings with you. So if you're in the sort of the same boat where you've had eventualities, urgent matters like paying bills or fixing toilets getting in the way of your climate research, which is an important matter and becoming an urgent matter, stay tuned. So right here, you'll see as of yesterday, it was announced that 2023 was declared to be the hottest year ever recorded for the planet Earth. This chart goes back to the 1940s, blue lines, 50s, 60s, 70s, white lines. Every year, statistically speaking, it's getting a little bit warmer. And before there was global warming or climate change, there was a couple people were looking into what is the atmosphere. We didn't even know that in the 1850s. So John Tyndall was one of the guys researching this in the late 1850s, 1860s, and he wanted to know what was keeping us warm, because in fact, when infrared light hits the Earth at nighttime, all that heat could just shut off, right? So there has to be some type of blanket over the Earth, and that he surmised was the atmosphere, and he wanted to know what the atmosphere was composed of. And so he developed this machine here. He put in different gases. He put infrared light at one side and wanted to see if it would get to the other side. And he put oxygen in. Of course, the heat light made it straight through. Nitrogen gas made it straight through. CO2, not so much. It got stuck in that tube, heated up the tube, not as much made to the other side. Same way with methane. And so he realized that these were likely gases that were trapped in some level above the Earth's surface to keep us warm at night. And so not much was thought about this whole study until 100 years later, when Dave Keeling got a chemistry degree in Illinois. Most of his friends who got similar degrees went into oil and gas research and exploration. He did sort of the opposite thing. He went to Caltech and studied the effects of CO2. Okay, stayed in California, continued to do research, and eventually set up a lab on the top of Mauna Loa in Hawaii to do daily samplings of CO2 levels. Also did this in Tasmania and in Antarctica, and pretty soon other researchers were setting up their own sampling areas to be able to get CO2 levels. So from 1958 onward, we have very clean data of how much CO2 is in the atmosphere. But 1958, before that, we didn't know. And so about that same time, a guy named Claude Lorius did some research up in northern Russia, got these long ice spires here. He dug into polar ice, pulled the ice out, and you can see the tiny bubbles in there, and those bubbles contain CO2, but what's unique about this is they go back thousands of years, hundreds of years, different numbers of years, and the number of years can be discerned by doing radiocarbon dating. And so now we have very clean record of how much CO2 is in the atmosphere, basically from full history on backward, from today, from 58 on backward. And that number now, it was basically 285 parts per million. Number now is 423 parts per million. So scary number. What does that really mean? Well, 1850, you see here, still at around 265 parts per million, slowly increasing. 1900, all of a sudden taking off hyperbolically to that 423 level. And you see, it's not just, this was when Christ was a child, that last 2,000 years. So we're at 60% above now at 423 parts per million, but also back 800,000 years, up and down, but still channeling really between around 180 and 265 parts per million. And so what is that? How does that affect things? Well, yes, the temperature has also gone up. So this is from 1850 onward. Temperature on average has increased 1.48 degrees Celsius globally. Strange measurement because it's done for the whole year, right? So there are 5 groups of scientists shown here that are doing this measurement to make sure that it's accurate, because you're taking different samples, different parts of the world, and you'll see that really their data comes out very clean, very, very similar. And 1.48 degrees Celsius, around 2.8 degrees Fahrenheit. So yeah, the Earth's around 3 degrees warmer than it was 173 years ago. So if you look at this, there's pretty much a perfect correlation of the increase in temperature to the increase in carbon dioxide. And there are also things like El Nino, La Nina that affect the water temperature. So the water is sort of a heat sink, so different years are hotter or colder. And then there's also methane in the atmosphere, but basically a 1-to-1 correlate in our value of 1 with the increase in temperature for the level of CO2. So what conclusion do you have about this? I myself think that there may be something to this idea that global warming is caused by CO2. And so, so what? Well, what's happening now is, this also was announced yesterday, there were $28 billion disasters happening in the United States last year with a value greater than $1 billion. And you could say, well, Dave, yeah, but there's inflation. We're in a high inflation time period. Well, all this has been adjusted for inflation. And again, last year, off the charts, high number of disasters. And 4 of the last 5 years have had record number of disasters. And so we probably can remember back, this seems like it was longer ago, but actually just in August, Lahaina in Maui, unprecedented, no one expected this. 100 people died in that. In Canada, over the summer, there were 45 million acres torched. Again, about double of any fires that Canada had ever seen. And in fact, that was so major that indeed did affect the level of CO2 in the atmosphere by around 5%. So we're in this spiral to hell, in effect, where the warmer it gets, the more fires there are because everything's drier. And the more fires there are, there's more CO2. And so, obviously this needs to be solved. By the way, same way as it's getting warmer, because it is warmer, the clouds actually can hold more water, so there's more flooding that's been happening as well. And so how does this affect you personally? Well, it may be affecting you if you live in one of these darker red states, because if you own a house, your property insurance has probably gone up. In Texas, really a double whammy recently. Last summer, super hot in northern Texas for like a month, extreme heat. And then in February of 2021, there was extreme cold, 2 degrees below 0 Fahrenheit. And you can say, well, Dave, how can there be global warming when it's getting to be this cold? And that's where the word had to be rechanged to climate change versus global warming, because if the polar region actually is the first thing to warm up. And so when that warms, there's less, the jet stream is not able to hold a barrier as well between super cold, super warm areas. And so that jet stream is it's easier for it to float down to our lower 48 here. And that's what happened in Texas. And yeah, the wind energy, solar energy, natural gas, a lot of things froze up there. Really a bad situation. And unfortunately, we may be seeing, it may get worse before it gets better. But it actually is going to get better. And the reason is there's two groups that are working to make it better, both government and private industry. And government is actually pledging to do something about this. So China, biggest emitter, 28 to 30% of global warming comes from China. And in fairness to them, they're also doing more production probably than anybody else these days. So anyway, they have pledged that by 2060, they're going to become carbon neutral. The United States is pledging carbon neutrality by 2050 and India by 2070. And so these are three of the biggest polluters. Europe does its share as well. But what carbon neutrality means is that instead of emitting more carbon in the atmosphere, there's actually going to be some carbon that's going to be sequestered, and such that there's going to be zero carbon emitted into the atmosphere. And so how are we going to do that? Well, first of all, the cost of solar is really falling exponentially. At the same time, a lot of energy rates and utility rates are increasing. Solar rates are projected to be, by the end of 2025, 10 cents a watt. Okay, so back in the 1970s, $75 a watt, 10 cents a watt. Basically, it's almost be free. Now, this is wholesale pricing, of course, for solar, but yeah, solar is getting super cheap. And also the cost of storage is coming down. So solar plus storage, no brainer here in the West. If you're in a cloudier area, as efficiencies get better, it's also going to work for you there. And that brings up this concept of the DC nanogrid. So the computer you're watching this on probably, or television, are DC appliances. They have a little box connected to them to rectify the power. You shouldn't need to have to do that box, folks. You should be able to run your appliances that are inherently DC off of DC. Electric vehicles inherently DC. AirSpool, we're involved with solar-powered heat pumps. Solar is DC, so the power comes into that unrectified, runs on DC power. So all these things are going to be able to run off of your own DC nanogrid in the future. At least that's the vision for a lot of people. And meanwhile, the monitoring that's going on with different appliances, with IoT devices, everything's getting more efficient. And these are all sort of carrot things where there's money to be saved for individuals or for companies, but there's also the stick of government, and that's they're going to require carbon capture of both industrial production and power plants in the next few years. And so when carbon's produced, it's not going to be allowed to be in the atmosphere. It's going to have to be captured and kept on site or in the ground at the industrial sites where they were burned. And finally, you've probably heard about in the past, like in Brazil, all the deforestation. Good news happening now, there's actually reforestation where trees are being planted all over the world. And trees do something called photosynthesis, which uses CO2 gas. And that's a wonderful thing. So that's going to be another way to diminish the amount of CO2 in the atmosphere. So I think we're heading on the right track here. I'd ask you to keep climate change in mind. Be open to solar if you're not already engaging in it. Our channel here on YouTube is called AirSpool. Check it out. Check out airspool.com. Appreciate your time. Thank you.